Have you ever gone out of the city to watch the night sky? You may notice that there are many stars out there. In fact, if you have done this plan often, you could figure out that some stars change their period by the time, having peaks and valleys. These stars are called variable stars. Our research is about Cepheids, a very special kind of these stars. Now, please imagine that you can see a car from your window at night. You must figure out how far it is by paying attention to the car lights. If the car lights are weak, you may conclude that the car is far from you. On the contrary, if the car lights are strong, you may conclude that the car is near to you. Now, do you remember the stars I just talked about it? Cepheids are not only variable stars, but also they are periodic. That means that a Cepheid spends almost the same time from one peak to the next one. This time is called period, and each Cepheid has its own period. Henrietta Leavitt in 1912 discovered that there is a linear relationship between the logarithm of the period and the Cepheid brightness, stating the Leavitt law. This law could be used to estimate distances in the universe. The main idea in simple words is that by the law we can estimate the Cepheid brightness and compare it with the brightness we perceive here on Earth to measure the distance. However, the Leavitt law is not just an equation. It must be estimated by statistical methods. We discovered that the statistical method commonly used to estimate the law is not adequate. Besides, some Cepheids must not be considered into the model because of their astrophysical properties and other non-statistical reasons. That's why we moved to robust methods that allow us to deal with the problems we have found. It's very important to improve the way the Leavitt law is estimated because it is used to adjust other more powerful methods that allow us to measure distances to even further objects in the universe. We are not trying to map the universe, we are improving the sextant that we use to surf on it. My name is Jaime Roberto Muñoz Luque. I am industrial engineer, Master of Science in Engineering, and I am studying my PhD in engineering at the University of Los Andes. This study is called The Influential Effect of Blending, Bumping, Changing Period and Eclipse Effect on the Leavitt Law. It was published on the Astrophysical Journal in 2016.